Assalamualaikum, my name is IZZATI. This is my group, FATIHAH, NURAZWARINA NADIA, and me, IZZATI. For agenda, we decide to divide 3. So, Carnot and Story Cycle, present by me. Auto Cycle and Rankai Cycle, present by NURAZWARINA, and Cell Cycle and Brayton Cycle is IZZAH FATIHAH. So, Carnot Cycle. Carnot cycle is an ideal closed thermodynamic cycle with reversibility. Study Carnot utilized that heat energy is transferring from a heat resource. Carnot cycle composed of 4 reversible processes, which also mean direction can be turned to original position. French scientist Sadi Carnot discovered the Carnot cycle in 1824 and others developed it in the 1830s and 1840s. So for process 1 to 2, temperature is constant or not changing in this process. Heat energy from heat source is transferred into the ideal gas. As a result, the gas expands, which then increases the volume and decreasing the pressure. Process 2 to 3, there are no heat transfer between the surrounding and your system. All change in temperature is contained within the system, which as a result making the entropy zero. In this process, volume are increased and pressure decreases. Process 3 to 4 by compression means volume is decreases and then the pressure is increased. In this process, heat energy is then transferred into the heat sink. Process 4 to 1, all change in temperature is contained in system and entropy is zero. Since this is compression, it means volume is decreases while pressure increases. The advantage and disadvantage for this cycle is Carnot cycle is an ideal cycle that gives maximum efficiency among all the cycles available. For disadvantage, it is impossible to supply heat and reject the heat at a constant temperature without phase change in the working material. Advantage, Carnot cycle helps in designing the actual engine to get maximum output. Disadvantage, it is impossible to construct a reciprocating heat engine to travel a piston at a very slow speed from the beginning of the expansion to the middle of satisfied isothermal expansion, and then very rapid to help the reversible adiabatic process. Advantage, it helps to decide the possibility of any cycle to build. As long as the engine maintains efficiency less than Carnot, the engine is possible, otherwise it is not. Next is Stirling cycle. The Carnot cycle, which is thought to be most effective thermodynamic cycle, and the Stirling cycle are most comparable. The Stirling cycle is a thermodynamic closed cycle invented in 1816 by the Scottish minister Robert Stirling. It was used as an engine and was considered at the time to be capable of replacing the steam engine, since steam boilers were prone to life-threatening explosion. For the process 1 to 2, in this cycle, it has isothermal heat addition at hotter temperature, or the higher temperature within the cycle. The way that achieved is by adding the heat while expanding at the same time. Process 3 to 4, where the constant temperature whereby the pressure is going up, and that the process where it is rejecting heat at the same time, enabling to stay at a isothermal condition. And for process 2 to 3 and 4 to 1, another aspect is Stirling cycle, that this cycle has generator. What the generator does is to take thermal energy from one part of the cycle and transfer it to another part of the cycle. that is shown in previous diagram. What happened to process 2 to 3 is it being transferred to process 4 to 1. For advantage and disadvantage for this cycle, the advantage is high efficiency engine, direct conversion from thermal energy to mechanical energy. Mechanical energy could be applied to cooling the facility. Disadvantage, very complicated and experimental, may require higher temperature to work without special gases. Special gases may not dissipate enough energy to keep the panels cool.
Assalamualaikum and good evening. So today I will present the auto cycle for the Bmmh thermodynamics subject. So for the auto cycle involves 4 engine strokes and a stroke defined as a process in which the cylinder piston moves up to the top of the engine or down to the bottom of it. Otto cycle introduced by a German engineer named Nicholas Otto, born on June 10, 1832 in Hausen-Nassau, Germany. He was the one who credited as the first creator of a petroleum combustion engine operating under a 4-stroke cycle. The machine that he invented during that time was the first practical alternative to the steam engine as a power source. For the process, as shown in the TS diagram, at process 1 to 2, this process occurs after the intake process. At a SI engine case, intake is a mixture of gasoline and air that is also known as charge. In this process, the charge is compressed in an isentropic manner. At process 2 to 3, during this part of process, the fuel gets blasted with the help of external spark, where the engine known as the spark ignition engine. During this process, the volume of heat addition process was constant. At process 3 to 4, after the combustion process, the exhaust of the gases was expanded, and this process was called as an isentropic expansion process. And the last process at process 4 to 1, after the expansion process, the exhaust valve was opened. This has resulted to a sudden drop of pressure inside the engine cylinder. This process has constant volume of heat rejection process. For the advantage and disadvantage of the Otto cycle, for the advantage part, it is a good reliability. The petrol engine has a low cost and outstanding ratio of power to weight. But the disadvantage of the cycle is it has low compression ratio, less efficiency than a diesel engine, and extra spark plug needed to do the combustion of the air-fuel mixture, which need an extra cost. The fourth process was Rankine cycle. The Rankine cycle, also known as a Rankine vapor cycle, in one of the thermodynamic cycles that act to convert energy known as heat into a mechanical energy, which is something that moving. Rankine cycle first invented by a Scottish engineer named William J.M. Rankine. He suggested the theory of the steam engine in his famous manual of 1859. For the Rankine cycle process, at process 1 to 2 to 3, it is the isobaric heat transfer. High pressure liquid enters the boiler from the feed pump, and then it is heated to the saturation temperature. A further addition of energy can cause evaporation of the liquid until it is fully converted into steam. At process 3 to 4 is an isentropic expansion. In the turbine, the vapor expanded and thus producing work that can be converted to electricity. In practice, the expansion was limited by the temperature of the cooling medium and by the erosion of the turbine blades by liquid entrainment in the vapor stream as the process moves into the two-phase region. Vapor that exits should have a quality of more than 90%. The third process, which is at process 4 to 5, is an isobaric heat rejection. The vapor-liquid mixture leaving the turbine in the condense at low pressure, usually in a surface condenser using a cooling water. In well-designed and maintained condenser, the pressure of the vapor is well below atmospheric pressure, approaching the saturation pressure of the operating fluid at a cooling temperature. And last but not least, at process 5 to 1 is an isentropic compression. The pressure in the condensate is raised in the feed pump. However, due to the low specific volume of liquids, the pump work relatively small and often neglected in thermodynamic calculation. For the advantage and disadvantage of the Rankine cycle, the advantage is it is cheap and widely available, non-toxic to the environment, and has low viscosity. For the disadvantage, it has a big installation needed to perform the process, high cost needed as the expensive multi-stage turbines needed, and efficiency loss and limited suitability to recover the waste heat. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is FATIHAH binti JOHARI. My matric number is B092110246. I will talk about DC cycle. DC cycle is a combustion process which is burning of diesel fuel take place and charge retrieved from the burning of diesel fuel. The diesel cycle is also referred as the constant pressure cycle. The diesel cycle is used in heavy vehicles like generators, cars, and trucks. For working principle, the first one is suction process. The suction process is when the air is entered into the cylinder. The second one is compression, and third process is expansion, and lastly is exhaust process. When the cylinder having charge which are released into the engine through the exhaust port. During this process, inlet valve is open and exhaust valve is closed. So this is how the diesel cycle process takes place. For cycle diagram, at process 1 to the process is isentropic compression, and at process 2-3, the constant pressure heat addition is happen. In this process, the heat is added at a constant pressure of the system. At process 3-4, the isentropic expansion process is occurring. In here, the fluid is getting expanded, which means the work is being out and the temperature is decreasing from 0.3 to 4. At process 4-1, at the process 4-5, the constant volume heat rejection is hampered. The heat is being rejected and the pressure is decreasing at a constant volume process. Advantage of this cycle is first one is highest effective efficient of all combustion engine. The second one is the diesel engine can combustion a huge variety of fuel. And for the disadvantage, firstly it is the car that use diesel engine usually cost more than a standard vehicle. And the second one is the cost of diesel fuel is very pricey. For next cycle is Brayton cycle. Brayton cycle or sometimes referred as Joule cycle or sometimes called as gas turbine cycle. The Brayton cycle describes the workings of a constant pressure heat engine. The Brayton cycle is one of the most common thermodynamic cycles found in a gas turbine power plants or airplanes. Brayton cycle is used in a jet propulsion unit in aircraft, in ship as propulsion unit, and in supercharging system in automobile. The open system turbine mainly used in airplanes. There is three components for basic Brayton cycle. That the first one is compressor, the second one is expander, and a mixing chamber. While modern Brayton engines are always a turbine type, although Brayton only made piston engine. For working principle, the first one is the compressor that draws air into the engine, then pressurize it and feeds it to the combustion chamber. The second one is the combustion system. The combustion produces a high temperature, high pressure gas stream that enter and expand through the turbine section. The third one is the turbine. Is an intricate array of alternative stationary and rotating aerofoil section blades. For the cycle diagram, the process 1-2 is isentropic compression process. And in here, a slight increase of temperature of gas occurs due to compression. The volume of the gas decreases since it is in compression process. Then for process 2-3, it is isobaric heat addition process. In here, a little rise of volume happens due to heat addition. The temperature of the gas increases since it is a heat addition process. For the process 3-4, it is isentropic expansion process. The temperature is slightly decreased occur due to expansion since it is an expansion process. Volume of the gas is increased. Next is the process 4-5, the isobaric heat rejection process. Since it is a heat rejection process, the temperature of gas is decreased. A slight decrease in volume happens due to the heat rejection. For advantage, first one is it requires less space for installation. Second one is it has a very high power to weight ratio. Third one is it generates less vibration compared to the reciprocating. For the disadvantage, firstly is more of power is used to drive the compressor so it give less output. Second one is it cannot start easily because compressor is driven by the turning itself. So an external unit is required to rotate the compressor to start the turbine. Third is overall efficiency of turbine is low because exhaust gases contain most of the heat. Suggestion to improve the cycle. The cycle can be improved with increase the pressure ratio. With increase the pressure ratio, the efficiency of the Brayton cycle also will increase. That's all. Thank you.